All right, everyone. Um, Hopefully you still remember this question we discussed before. Suppose we test a smart drug that claims to be able to increase people's IQ scores, and the result experimental is 1 or 2, control is 100, and then we skip to p equals a 0.04. Of course, we skip this big step. Actually, is that data analysis involves a lot of calculation. Um, Now the thing is, there are a lot of different tests for different situations. Um, but the point is, all the tests they have one thing in common. They all test hypotheses. Um, More specifically, they test null hypothesis. Now, this kind of test we want to talk about are called parametric tests. So let me show this. Okay, parametric test. The definition is inferential tests that are based on assumptions about a population. Now, what are assumptions? Before conducting the test, we need to make sure that there are certain conditions or assumptions that are met. Maybe you can think of this as marriage. Marriage itself is kind of like a test, right? And before you jump into this test, you need to make sure there are certain conditions met. So, for example, you make sure your partner loves you, you love your partner, your partner doesn't marry you out of pity or money. Like in my case, my wife married me out of pity, and she thought I could be saved, but I was beyond repair. Anyway, so so there are certain conditions that need to be met. So like this test, if those conditions are not met, either we have a difficulty to interpret the data or need to interpret the data with cautious, or we just cannot conduct this test at all, right? All right. So this time, take a look at those assumptions. Now your book lists only 3, I think, but I give you 5. Okay, so for the exams, you need to go for the 5. The first one is probably the most important, most significant one. Interval or ratio scale of measurements. Hopefully you still remember the scale of measurements. Okay, let me show you this example. For example, if you ask a date to say, do you want to go out with me? Yes or no? Now that actually is not a good question. A better question would be, on a scale of 1 to 10, how much do you like to go out with me? From 1, yuck, to 10, absolutely. Of course, if you really get a date, neither question is good. But for the sake of our research, this will be a better one. All right. In other words, this is a Likert type scale. This is interval scale of measurement, and this is categorical. If you use this kind of questions, this kind of data cannot be analyzed by parametric test. Okay. So as I said, the first one, most important one, interval ratio scale of measurement. The second one is the participants are randomly selected. Because of course we want to be sure that the sample represent the population. But of course it's pretty much always violated, as we discussed before. So we must be cautious when generalizing the result. But we can go ahead and just conduct the test. The third one is a normally distributed data, because the normal distribution is a very important assumption. That means some of the data from one or more normally distributed populations. Now, this assumption is kind of quite often being violated, but it's not really a huge deal. We usually just go ahead and analyze the data. And if it is really, really bad, really, really skewed, then we can transform the data. But you don't have to worry about this. This is just so you know. Okay. The fourth one is more like a research design. We assume all the participants are independent from each other. Those answers, those data, the behavior or the answer of one participant does not influence another. So, for example, if I want to know how much people, how much students in my class are like the class, if I ask in front of everybody, say, hey, how much do you like the class? Well, I'm not going to get an honest answer because they look at each other, right? Their answers will be influenced by each other, and they are afraid if they've been honest with me, I'll fail them. So this is not independent. Okay. So to be sure it's independent, we need to like answer anonymously without looking at each other. Okay. Finally, population variances are equal, and this is called the homogeneity of variance. And please, everyone, please remember this word, homogeneity. Okay. Now, this assumption means some of the variances should be the same throughout the data. Let me show you the graphs. So, look at here. It's a little bit small, but hopefully you can see it clear. This one, you see the data spread out quite evenly, right? Now, how about this one? You see the data kind of like cluster around here. And as go to this direction, the data start to spread out. Then this is not evenly. This is not homogeneity. Another one, you look at this, this is more obvious. Those data clustered together right here, and that this is quite spread out. You see here, no data point. Then this is not homogeneity. And this is the same. Clustered right here, and then spread out right here. This is not homogeneity. Usually we assume is homogeneity. Our data looks like this, or approximately looks like this. Okay, so the test still can be conducted even if some assumptions are not met. Of course, to this point, we know some assumptions are more important than the other. But in most of the cases, as long as it's interval scales, then you can go ahead and just analyze it. And it still can the test still can be conducted because those tests are robust. And please remember the definition of robust. That means not easily influenced by the violations of the assumptions. Okay, so in other words, yes, those conditions, some conditions probably are not met, but it's okay. We still can go ahead and conduct the test. It's just we need to proceed with caution. Okay, I guess it's a little bit like marriage, right? Some certain conditions probably are not met. Not perfect. No marriage is perfect, but we just go ahead and just get married and work on it, right?